Oke guys, kita bakal lanjut belajar. By the way, hari ini adalah hari pertama kuliah. Jadi tadi, ah, udah tuh bareng. Sebelum makan guys. Halo men.
By now, you should be pretty familiar.
Subtitlenya
Hey
tuh
guys,
biasanya rusak
when we
guys.
learned about
Jadi aku agak kesusahan ya belajar. Subtitlenya itu kenapa ya masih rusak?
SQL, we looked at how to create
Nggak tahu
tables.
aku nekan yang salah atau apa, websitenya emang error, tapi subtitlenya nggak muncul.
Hey guys, when we learned about SQL, we looked at how to create tables using the SQL language. Well, this time, let's take a look at some of the specifics when it comes to creating tables using Postgres. By now, you should be pretty familiar with the idea of tables. We have tables where there are the vertical parts, which are our individual columns. So imagine a Roman building with lots of columns. They are always vertical, holding up the entire table. And of course, the columns represent different fields. For example, there's a field called name, there's a field called age, and we can keep adding more and more of these fields and the different characteristics of the data that we want to capture. For example, in this case, I am building a table of friends because, of course, as programmers, we don't have that many friends, so it's good to track them in a spreadsheet. Now, if you're somebody who has lots of friends, then you'll have an even greater need to track your friends in a database. And if you think this is completely ridiculous, don't worry, this is just an example for us to learn databases and tables. Now, the other aspect of the table is the row. So these are the horizontal parts of our table. And I'm just drawing a really bad rendition of a rowing paddle here. They look like big spoons, but you get what I mean. These are the horizontal parts of the table, and they represent individual records of data. For example, if we had a friend called Angela who is age 12 and is not very cool, then this would be our first entry of the table, and all data in this row correspond to this particular person or this particular entry. We can have as many records as we want. And you might think, tables, okay, I use Excel, spreadsheets, it's all the same. But one of the biggest downsides of a spreadsheet, for example, is that you can only really have so many records before the spreadsheet becomes really kind of paralyzed and slow and difficult to load. Have you ever tried opening up an Excel spreadsheet with over 5,000 records? It's extremely slow to load all of them up. And this is probably the point where people start moving on to databases because they're extremely efficient at handling lots of data, and you can have millions of records and it wouldn't even blink. We've seen this concept of tables. We know all about tables from spreadsheets, and we now know that when we have a database, essentially what we have is just lots of tables tied together with some relationships and also with some rules that define how they should behave. You've seen previously that we can create a table in the SQL language simply by writing code like this. There's the keyword create table, and then afterwards comes the name of the table that we want to create. For example, in the previous version, it would be friends. That would be the name of our table. And then we have an open parentheses, a closed parentheses, and a semicolon to define the end of this block of code. And in between the parentheses, we've got all of the fields that we want to create. First is the name of the field. So, for example, that would have been the name of our friend. The second field would be the age of our friend. And the third field was the is cool factor. And then after each field comes a space, and then we get to define the data type. The data type of SQL is a little bit more limited than the data types that are available in Postgres. But either way, you've seen data types like char and varchar, so characters, or something like Boolean for true or false. And there's lots and lots of other ones that we're going to talk about just in a moment. If we were to create this table of friends using SQL and creating it inside Postgres, this is the code that we might use. Firstly, we've got that keyword create table, and then we've defined the name of the table as friends, and then in between the parentheses we've got all of our fields that we want to define. So the first field is the ID, and the ID is a primary key. So what this keyword does is it ensures that any of the entries that go into this field must be unique, and it uniquely identifies each record. As you can imagine, you might have another friend called Angela, but if you were to search for all the records with the name Angela, there'll probably be many that will match that criteria. But we want to be able to always uniquely identify each record in our table, and that is the job of the primary key. This field cannot repeat, but in addition, we've got this handy Postgres keyword serial, which means that if you add a new record now, you don't actually have to specify the ID of this third record. It will automatically auto-increment from the previous record and give it a number 3. That's pretty handy. The next field we have is our name field, and we've set it to varchar 50. So this stands for variable character, and what it means is that this field will limit the data size up to a maximum of 50 characters, but if you have less than 50 characters, say for example if you just have the word Jack 4 characters, then it will decrease the size of that data block so that you are efficiently storing your data. In contrast to, for example, char, if I had defined this field as char 50, then it is going to give me enough space to store 50 characters no matter the size of the actual data. So this varchar is a slightly more efficient way of storing data. Another one you might come across when you're using a lot of Postgres is a data type called text. Now, text is also a flexible storage data type, so it will decrease the size of the data to whatever it is you need, but it doesn't require you to define a maximum size. In olden days, a lot of people recommend that we use varchar and define the maximum data size because this is the most efficient way of storing the smallest size of data. But in modern testing, and I've seen a lot of people running efficiency tests and speed tests and working with really, really large databases, millions and millions of entries, and people are seeing that the text data type doesn't actually take up all that much small space and isn't actually all that much slower. It is a little bit slower, but compared to the gains that you get by not having a situation where in the future you realize, oh, actually, I now have a friend whose name is super, super long, and I am one of those people. I have a friend where their surname is like 20 characters, and once I had to go and book a flight for them when we went on holiday, and I was reading out the surname of this Sri Lankan friend of mine who has a very, very long surname, and I started just cracking up on the phone because I had to read out all 50 characters of their surname. The point is, very often you'll see a lot of people using the text data type when they want to store characters over the varchar, and this is a more modern practice I'm seeing. But when you see varchar 50, this is the old standard best practice way of doing it. So don't be alarmed, either way is fine. It really depends on your use case. But in this case, I know that I'm going to refuse to make any friends who have a name that is more than 50 characters. And in many cases, you are storing data that you know has a maximum data size. But if you don't, and you want the flexibility, it's best to use text. Now, the next one is the age of our friends, and I'm storing it as an integer, a whole number, which is pretty straightforward. And then we've got the final one in our table, which is whether if that friend is cool or not. This is really a binary option, right? It can only be true or false. They're either cool or they're not cool. So we're storing it as a Boolean data type, and we can have that as false or true. As I mentioned, there are plenty more Postgres data types that you can dig into. And depending on your use case, for example, if you need to store a really big auto-incrementing integer for your primary key because you have billions and billions or trillions records, or you need it for some other reason, then you could use big serial instead of serial. Or, for example, when you needed to store the character varying, the varchar, variable length characters, or if you needed to store a date. And I recommend taking a look at the documentation here and just scroll through the different data types because there's a lot of explanation and you can read up more on things such as the different character types, as we talked about text, char, varchar, and it goes into more detail on all of these general purpose data types. Now, let's try this out for real. In the current lesson, you'll find a download to this file called capitals.csv. And CSV stands for comma separated values. And you'll see if you open up this file inside VS Code that it's exactly that. Each line contains a separate record, and each of the records are separated by a comma to show that they are in distinct columns effectively. The first line of our CSV happens to be the header, so it's kind of like the header row defining what is the name of each field. And there's only 3 fields: ID, country, and capital. And in each record, the capital corresponds to the country that is prior. The capital Afghanistan is Kabul, the capital Albania is Tirana, etc. We've got all of the countries in the world listed in the CSV, and we're going to create a table for it in our Postgres database. Download the CSV file and have it handy, because we're going to refer to this data to figure out how we're going to create our table. You'll notice that in this case, we have a perfect primary key, which is our ID field, because all of the IDs are unique. The next is our country field, which is the name of the country. So this is text. And in our case, we can define it as varchar 45, because I know for a fact that all of the countries in this list have less than 45 characters. And similarly, all of the capitals are text, and they also all have less than 45 characters. Once we have looked at the data and defined each of the data types we want to use, then we're ready to write some SQL code inside pgadmin to create a table. So I want you to go ahead and open up pgadmin. And when you first open it up, it might ask you to set a global password. This is the password for accessing pgadmin, and it's important that you write this down because there's lots of password involved in databases for some reason, and I always get confused which one's which, so it's a good idea to keep a track of that. When you go ahead and open up your servers on the left, you can double click on the Postgres SQL 15 database, and it will again ask you for a password. Now, this password is the one that you defined on the left. You can double click on the Postgres SQL 15 database, and it will again ask you for a password. Now, this password is the one that you defined when you installed Postgres. Remember previously when I told you that when you install Postgres, it tells you that your default username is Postgres, and you had to set a password. Now, in my case, I set it to 123456, but in your case, hopefully you've got something a little bit more secure, and more importantly, hopefully you've written this data down. So now you can go ahead and enter it when it prompts you. Don't worry if you forgot or something went wrong, you can always reset it, but it's a good idea to keep track of everything. Once you're here, I want you to expand this one that says databases, and by default, we get a database called Postgres. Now, I don't want to use this one because I'm going to create one of our own, and to do that, we're going to right-click on databases. We're going to say create database, and we're going to give our database a name. So my database is going to be called world. That's it. The owner is our default user, Postgres, and we can go ahead and simply hit save. So now we have our 2 databases, Postgres and World, which we just created. If you go ahead and expand schemas and then take a look inside tables, you'll see that there are currently no tables. So let's go ahead and create a table. Having selected this database, I want you to go ahead and click on this query tool. This is the place in pgadmin where we can write SQL code. As you might remember from previously, in order to create a table, we write create table, and notice how it's very in right and click on this query tool. This is the place in pgadmin where we can write SQL code. As you might remember from previously, in order to create a table, we write create table, and notice how it's very helpfully highlighting your keywords. So if you somehow make a typo, like create tabel, then you should be reminded that there's something wrong because it's not highlighting it correctly. Let's create a table, and I'm going to call it capitals. And once we've added the name, I'm going to add a set of parentheses. And at the end of the parentheses, it's important to remember to add a semicolon. Unlike JavaScript, which is kind of nonchalant about these kind of things, it's like, oh, you missed a semicolon. Sometimes it can, sometimes it doesn't. In SQL, it's very important that you end each of your lines of code with a semicolon. Otherwise, it's not going to work. Now we get to define our fields. So remember, our first field was ID, and we're going to give it the serial data type. Now, in our case, it doesn't really matter because we're going to import data that is already serial, that we've already defined, but it's good practice. Whenever I'm creating a primary key, which is usually called the ID field, I like to have it named as serial in Postgres, because then if I add any new entries, it's going to automatically work this out. So I don't have to look through the database, look at what's the ID of the last entry, figure out this kind of stuff. We're going to leave it to the computers. Now, the next constraint I'm going to add is, of course, our primary key. There's lots of constraints in Postgres, such as the unique constraint or the not null constraint, and we'll see this in later lessons when we cover these different constraints. But for our ID, the only constraint we need to tell it is that this is the defining field for each record. It will be unique for every single record. That's our promise to Postgres. The next one, we want to call it country, and it is going to be a text data type. As I said, it's for the constraint or figure out the serial in Postgres that we've already set our fields. So remember, our first field was ID, and we're going to give it the serial data type. Now, in our case, it doesn't really matter because we're going to import data that is already serial, that we've already defined, but it's good practice. Whenever I'm creating a primary key, which is usually called the ID field, I like to have it named as serial in Postgres, because then if I add any new entries, it's going to automatically work this out. So I don't have to look through the database, look at what's the ID of the last entry, figure out this kind of stuff. We're going to leave it to the computers. Now, the next constraint I'm going to add is, of course, our primary key. There's lots of constraints in Postgres, such as the unique constraint or the not null constraint, and we'll see this in later lessons when we cover these different constraints. But for our ID, the only constraint we need to tell it is that this is the defining field for each record. It will be unique for every single record. That's our promise to Postgres. The next one, we want to call it country, and it is going to be a text data type. As I said, it's not going to be more than 45 characters. So I'm going to define it as a varchar brackets 45. And similarly for the capital, I'm also going to define it as a varchar 45. And remember that weird aspect of SQL, the last field cannot have a comma, otherwise it will give you an error. All of these other fields have a comma, and the last one, you leave it blank. Couple of things, little quirks to note, but this is essentially the code that we need to create our table. Let's go ahead and run this code, and hopefully you will have something green, and also it says query returned successfully. This means our table is created, but where is it? Well, let's go ahead and right click on this, click refresh, and hopefully you'll see your capitals table. If you right click on this and say view edit data or rows, then pgadmin is going to bring up your table. Now, our table is a little bit sad at the moment because we have no data in it. All we did was to create the table. Notice how our query
Shit.
area changed. It changed to select asterisk, which means select all, from public.capitals, order by ID ascending. This was
Order by
changed.
ID.
A little bit sad at the moment because
from public's capitals, public. What is public? I forgot about public.
you right click on this and say view edit data or rows, then pgadmin is going to bring up your table. Now, our table is a little bit sad at the moment because we have no data in it. All we did was to create the table. Notice how our query area changed. It changed to select asterisk, which means select all, from public.capitals, order by ID ascending. This was SQL code that was written automatically for us by pgadmin when we simply right-clicked on View Edit Data or Rows. Now, let's see what happens if I say first 100 rows. It's going to change the query to say all the first 100 rows on View Edit Data or Rows. Now, let's see what happens if I say a first 100 rows. It's going to change the query to say order by ID, ascending, limit to the first 100 records. As you can see, using pgadmin is a really great way to get access to a GUI or a graphical user interface where we can click and point and do all the usual things you would expect when working with a computer and without having to do all of this manually by typing out SQL code, which, as you can imagine, might have errors, you might forget, etc. So this is a really great way of working with Postgres, and I'd recommend everyone to use this rather than trying to access Postgres through the terminal or something crazy. Now that we've got our table successfully created, I want to show you one last thing before I leave you to do an exercise. And that is do
public capitals.
You can see rows. It's going to automatically ascend asterisk how our in it, you'll see your capitals table. If you right click on this and say view edit data or rows, then pgadmin is going to bring up your table. Now our table is a little bit sad at the moment because we have no data in it. All we did was to create the table. Notice how our query area changed. It changed to select asterisk, which means select all from public.capitals, order by ID ascending. This was SQL code that was written automatically for us by pgadmin when we simply right-clicked on View Edit Data or Rows. Now let's see what happens if I say first 100 rows. It's going to change the query to say order by ID, ascending, limit to the first 100 records. As you can see, using pgadmin is a really great way to get access to a GUI or a graphical user interface where we can click and point and do all the usual things you would expect when working with a computer and without having to do all of this manually by typing out SQL code, which, as you can imagine, might have errors, you might forget, etc. So this is a really great way of working with Postgres, and I'd recommend everyone to use this rather than trying to access Postgres through the terminal or something crazy. Now that we've got our table successfully created, I want to show you one last thing before I leave you to do an exercise. And that is how we can import data into our table. You know that you've already downloaded the capitals.csv, and we can import that data format CSV into our table in Postgres. And we can do that using pgadmin in a really simple way. Much simpler than if we had to do this manually. Right click on your table and then go ahead and click on import/export data. Make sure that here where it says import export, you've got it. Right click on your table and then go ahead and click on import/export data. Make sure that here where it says import export, you've got import selected. By default, I think it goes to export. And then we can select our file name. So if you go ahead and click on this folder and find where you saved that file, capitals.csv, probably in your download folder, then go ahead and click open, and it will add the file path to that file. Leave the format as CSV and then go into the options and make sure this check mark next to header is clicked blue to the right. What this is going to ensure is telling our import that the first line in our CSV is not actual data. It's not a record. Instead, it's the header for each of the fields. So now when you go into columns, you'll see that it's auto imported the names that's in that CSV and it's added it in here, the ID, the country, and the capital. Remember that when we created the table, I created the names of the fields as exactly matching the header. This is important. If you have changed your field names from, say, a capital C instead of lowercase c for country, or you've called capital something else, then it's important that you either change your CSV or change your table. Because otherwise something might go wrong and it might not know which one you're talking about, which columns to import, etc. If we go ahead and click OK, then it's going to perform the import process, and hopefully you're getting all green pop-ups saying process completed. And if you had any issues, such as you need to rename your fields, you can simply right-click, click on Properties, go to Columns, and then edit each of the names here and make sure you hit Save. And once you've got all of that of the click on Properties, go to your fields, you can simply right-click, click on Properties, go to Columns, and then edit each of the names here and make sure you hit Save. And once you've got all of that matching, then you can try the import process again. So now let's go ahead and right click on our table and click refresh. And we can go to view edit data or rows. And you'll see we now have lots of data in our database. And it's and we can go to view edit data or rows. And you'll see we now have lots of data in our database or rows. And you'll see and we can go to view edit data or rows, and you'll see we now have lots of data in our database, and it's imported all of those countries and their capitals. Now we can go ahead and use this data in our database, which is what we're going to be doing in the next lesson. We're going to be building out a world capitals quiz. But before we do that, I want you to get a little bit more practice doing this. And so I have created another set of data for you to create a table and to import it. The exercise for this lesson is to download the other file in this lesson, which is called flags.csv. And if you open that file up in VS Code, you can see what the data looks like because it's also a comma separated value type data. Here we have the header. It's got ID, name, and flag. And then we have each of these records. For the flag, it is an emoji. An emoji is basically a UTF-8 data type. It is essentially stored as text. And when that text is recognized by a computer, then it will know to pick an image to display in its place. Now, you can either store this data type as a varchar, but I recommend using the text data type because it's by a computer as text. And when that text is recognized by a computer, then it will know to pick an image to display in its place. Now, you can either store this data type as a varchar, but I recommend using the text data type because it handles UTF-8 a little bit better. And you get to try out a different data type, UTF-8, a little bit better. And you get to try out a different data type. pause the video now and try and create a table in your Postgres database. You can call the table flags and go ahead and add all of these fields in your create SQL code and then import this file into that table. And hopefully everything going well, you'll have another table with all of the data of each country and their flags. So pause the video, give that a go now.
Okay.
All right, just as
Let's wait. Oke, saatnya ngetes. Ada semangat in my eyes, it comes true. So my life is how I waktu. I got semangat of my life, it comes true. Na, 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 na. It's Postgres. Besok masuk jam berapa ya? Selasa. Besok siang juga. Lah, praktikum lagi. Selasa. Are you sure? Kok aku takut ya salah lihat jadwal. Sumpah aku ya hal yang berhubungan sama jadwal ini udah trauma banget. Ini harus dikontrol. Ya cuman satu jam 12 di ruang lab RPL HU itu apa? Herman Yohanes kan? Lab RPL HU. HU itu kayaknya Herman Yohanes deh. Ya nggak di TILC lagi. Orang pengen di TILC. Bagus. Mari kita lihat apakah aku udah menyimpan nama kelas di sini. Nih keterangan kelas. I have to save it. Maybe screenshot it. H. Gedung HY. Skip 3. Skip 3 itu apa maksudnya? Lah, banyak di HU-nya, Cok. HU lagi. HU lagi, HU lagi. C, C, H, C, H, C, C, M. Oh, banyak di C ya. C itu Gedung Cahyono itu mana? Gedung Cahyono. Gedung Cahyono itu ada di Gedung Cahyono. Lah, dikasih tunjuk dong. Emang beneran ini Gedung Cahyono? Are you sure about that? Yang gerbong Gedung Herman Yohanes. Kok Gedung Herman Yohanes? Coba ya Gedung Cahyono. Gedung Cahyono di skip. Gedung Cahyono Adi skip 4 GM. Cahyono. Cahyono. Coba ini dulu deh. Kabarnya, geng? Oh, ini namanya gedung Cahyo. Berarti besok Selasa jam 12 ya? Oke, cuma satu anjir. Sini kita server. Sini kita uh, create database and name is work work and we click save and we open the word and we open the schemas and we go into the table. Eh, import table kan? Ow! Goblok, goblok anjing. Kagak ada tempat yang lebih bagus. Astaga, goblok. Tai. Ada. Sini kita tinggal tekan import table. Hah? Di mana ya tadi import? Cepet kali aku lupa ya. Import di bagian mana ya? Jir, cepet kali aku lupa ya.
And world, which we just create on this. Be reminded through the database of it to the computer. Change tools. Use this rather than trying to access Postgres through the terminal or something crazy. Name. So if you go ahead and click on this folder and find where, then if we had to do this manually. Right click on your table and then go ahead and click on import/export data. Make sure that here where it says import export, you've got import.
Oh, harus create table dulu. Oke, kita like flex. Save and gonna import. Spreaded comma ID name template. Oh, aku salah cok. Hapus. Delete this. Yes. Oke, gas serius. I get to night off one night. Because you. First one is ID. It type address serial and its primary key. And then there is a name. It's varchar. It's maybe, I don't know, and there is a flag. It's text. Terus cara entering. Oh ini udah. Hmm, ya terus kita tinggal import data and we use this option header and we go to the columns. Okay. Terus oke semua udah ada sini. Terus ya udah.
Selected. By default, I think it goes to export. And then we can select our file name. So if you go ahead and click on this folder and find where you set the path to that file, this check mark is not names that's in that CSV. Remember that when we created the table, I created the names of, I don't know which one you're pop up saying process completed. Please go to columns and then edit each of the names here and make sure you hit save. And once you've got all of that matching, then you can try the import process again. So now let's go ahead and right click on our table and click refresh. And we can go to view, edit data or rows. And you'll see we now have lots of data in our database. And it's imported all of those countries and their capitals. Now we can go ahead and use this data in our database, type data, a little bit better. And you get to try out a different data type. Pause the video now and try and create a table in your Postgres and code with selected topics, second field. So, and this finally, we now is that there's another way of creating tables in pgadmin, which is to simply right-click each of the columns. In this case, it's actually better doing it use it, but each of the columns create table. You can add the name in here, you can define each of the columns, and you can do that by simply adding a new row. But I think in this case, it's actually better doing it using the SQL query. Not only because we've learned a bunch of SQL schema, for example, and for practice on making the location that and not shape it, we can see all of our data has been added here, and we can even see our little flags, which is perfect. Hopefully you managed to do that all right. And in the next lesson, we'll be using these databases that we created, and we're going to be reading the data in our database to create an actual quiz app. So for all of that and more.
Dia gambar bendera aku enggak ya? Flex. Oh to edit it. Create. Properties, maybe it comes. Kita gantiin dengan text. Sama aja. Kita ganti 45 deh. Save.
I'll see you there. Now that we've created our tables and we've imported some data into there, or you could have created some data fields of your own, it's now time to see how we can actually use that data in a real Node backend so we can power a project using data from our database. The project we're going to be building, as an example, is a capitals quiz. So I don't know how good you are on your geography, but mine is pretty terrible. But nonetheless, it's a quiz where you get a prompt for a country and you have to enter the name of the capital. So we're going to normalize the casing, we're going to get rid of any blank characters they add in there, but essentially we're checking whatever the user enters against what's in our database. And we know that we have the names of the countries and their corresponding capitals, and if the user gets it right, then they get to increase their score.
Where is my Ganti kan ya? Yes, no way. I know this is a
and up until the point where they get one question wrong, and then that's their maximum score. I'm not very good at this. My max score so far in the testing and playthrough of this has been 3, which is pretty abysmal. But you let me know once you've built it if you get a lot higher of a score. Essentially, this is what building very simple, but it's going to be powered by our Postgres database. To get all of that data, to get hold of all of those records, the line of code we need to read from our SQL database is simply this. Select all, so that's what the asterisk does, from the name of our table. The SQL code is very simple, and you've done this before, you know exactly what it does, but in order to implement it in our Node and Express backend, it takes a few more steps. We saw this when we first introduced you to Postgres, but now that we know a little bit more about Postgres, let's analyze this again so that we familiarize ourselves with how to work with Postgres and the pg-npm package in order to add a database to our backend. We're going to use this PG package, which simplifies things down for us vastly. And once we've installed it and imported it, then we can use it to create a new PG client. So this is basically connecting to our database. When we create this, we have to add some configuration details, such as what is the username, which, as you remember, defaults to Postgres. Hopefully you haven't changed that, and you should have the same username. The host, because we are hosting our database on our computer, that will be set by default as localhost, so also nothing to change there. The name of our database, which, if you remember, I asked you to call it world, which contains our 2 tables, flags and capitals, and the password, which corresponds to our username. So this is the password that we set up when we installed Postgres, and you might remember I asked you to write it down because it's used quite a lot, such as in this case, to connect to our database. We obviously wouldn't want some random person to connect to our database, so that's why you set up a password. When your database is locally hosted, such as in our case, it doesn't really matter because obviously nobody else can access your computer at the same time trying to access your database. But once this database goes remote, goes onto the internet, then these kind of things and setup becomes a little bit more important. The final one is the port number, and by default, Postgres will run on port 5432. And there is nowhere where we have changed that, so yours will also be, hopefully, 5432. Once we've created all of those configuration details, then we can use db.connect to connect to our world database. You might remember that the world database has lots of tables. That's why when we run our SQL query using db.query, we're going to run the code select all from the capitals table. That is going to be the table where we're going to be getting the data for our current project. And then we have a callback if there's an error, console log the error. If there are no errors, we're going to save the result.rows, so all of the data that comes from this line of SQL query, into the quiz variable so that we can use it in our quiz application. And then finally, at the very end, we close our connection to the database. And this is good practice so that you're not connected to it and you don't our quiz application. And then quiz variable so that we can use it query into the quiz variable so that we can use it in our quiz application. And then finally, at the very end, we close our connection to the database. And this is good practice so that you're not connected to it and you don't accidentally do something else or insert or delete your data so that you are closing off your session. And that is all there is to it, to connect to our database, to get hold and run the query that we want to run, and then finally to close the connection. Let's go ahead and do this in practice. In the current lesson, you'll see a zip file called World Capital Quiz. And if you go ahead and download and extract that onto your computer and open it inside VS Code, you'll see all of these files that I've lovingly prepared for you ahead of time. As always, first things first, it is to navigate to the file path and to install all the node modules by running npm install. So you end up with this folder, node modules. And once we've done that, take a look inside index.ejs. This is effectively our EJS file that defines this very simple quiz application. And we've got our main.css and the background image hosted in the public folder. So if you look inside index.js, you'll see that I've got the middleware where I say use express.static, defining the static folder as the public folder. So then we can link to it in our HTML and other parts of our code. I've already built the basic application, the back end and the front end for you. And I recommend simply to use this because we're going to be building in all of the relevant parts of this module, which is the Postgres, using the PG module, connecting to our database and reading from our database. If you want, you can, of course, create this completely from scratch. And to do that, all you need to do is run nodemon solution.js, hit enter, and then go ahead and open up localhost 3000. And here you will see the working version of the app using the solution. So you can try out the application. Don't worry if you don't know the name of the capital. You can always Google it. But I think Norway's capital is Oslo. So I'm going to type it in, hit submit. Hopefully I get it right. If I do, my total score goes up and you'll see a little check mark. And until we get to the point where I have no idea and I get it wrong and then hit submit, we get a pop-up, game over, final best score 1, which is pretty sad, but hopefully you can do better than me. You can look at this project and create all the backend front end by yourself using the assets that are available to you in the downloaded file. But as I said, I recommend actually to use the index.js as your starting point because there's a lot of new things and it's best that we concentrate on one thing at a time. But I'm going to walk through this code with you just so that we're all on board as to how it works. First, we've got our Express app running on port 3000. We have a quiz item that is an array, and it contains just 3 objects. The objects are essentially the records that are in our database, has a country and a capital. And of course, each being its own individual object means that they are linked to each other. So we can check the country against the capital. Now we've got a scorekeeper here called total correct, and then we've got our middleware to be able to use body parser to get hold of data from the form and to use the public so that we can have our static files, our background images, our CSS all working. If you go over to the index.ejs, you'll see that I've set up the EJS file so that we are porting over the total score. We are taking the question.country to display in that big H1 as the question. And then I've also got the input element to take the user input, asking them to enter the capital. There's some keywords on here, autofocus, autocomplete off, which means that that field is going to be selected when you first load up so that you don't have to click on it to type on it, which improves when you autocomplete off, which means that that field is going to be selected when you first load up so that you don't have to click on it to type on it, which improves the user experience just a little bit. But it's always the small touches that help. And the other thing that it doesn't do is it doesn't try to auto-suggest your past entries, which is not very helpful in this case. Those are the settings, and then it has the name of answer, which is what we're going to try and get hold of when the user clicks the submit button. The submit button is going to submit this form to the path of /submit using a post request, and we catch that over here in the post request. app.post /submit, and we can tap into request.body.answer in order to get the answer that the user typed in. You'll notice that I have this keyword trim here, and basically what this does is if the user types in 1, 2, 3, 4, and then they added a space at the end, or they added a space in the beginning, whatever it is, they can't see it, but of course that is not going to match up with whatever answer we have. Space 1, 2, 3, 4 is not equal to 1, 2, 3, 4, so we use trim to get rid of any of those spaces at the beginning and the end. Next, what we do is we check to see if the capital that they entered is equal to the capital in the current question. This current question object is set to be equal to a random object, so a random set to be equal to a random object is set to be equal to a random object, so a random record in that quiz array. We use the randomization method to get hold of a random object which has a country and also has a capital, and we set this current question to that random country, and we use it both to send the country over when we render the index.ejs, so we send over the current question here containing that country, and we also use it to check against the answer right here, so current question.capital against the answer that the user entered in the form. We're using to lowercase in both of these answers so that we can normalize the casing, so that we don't end up with the official answer for France being Paris, but then the user's answer is Paris and or vice versa. So this just gets rid of this problem for us, turning them both into lowercase, therefore making it match. Next, if the user was correct, if this is indeed equal, we increase their score, we log their total score, and finally, we set the is correct to true. And then we go ahead and set up the next question, pulling out the next country and capital pair, and then we render the index.ejs, passing over the new question, and also telling the JS file, whether if the previous answer was correct, and also updating the score on the front end. So I've tried to keep it relatively simple in terms of the backend and front end code. And at this point, if you have done all of the EJS and the backend sections, all of this, there's nothing new here. The logic is relatively simple. And I, in fact, really encourage you to go ahead and run this code as it is. If you simply just use nodemon to run the index.js in the world capital quiz and go over to the localhost 3000, you'll see that as you refresh on this website, you'll see the same question quite a few times because we're randomizing through just 3 entries: France, the US, and the United Kingdom. You can test out this very basic version. So London is correct, Paris is the capital of France, and you'll see this occurring, asking you for the same thing again and again, which is a lot easier of a quiz, but essentially, it has all of the basic working components and it should all be functioning. The step that we're interested in is to actually tap into our powerful database and to get hold of all of the entries in there. First, have an explore of your own, make sure you understand all of the existing code before we start adding new code, and then come back and continue with me. The first thing we're going to do is we're going to stop the server and use npm to install the package we need, which is pg. It's just lowercase p and g, and we are installing it onto the world capital quiz. Once we have done that, then we can use the pg package in here. So we can say import, and we're going to import pg from the pg module, just like that. And once we've imported it, we can go ahead and use it. And to use it, we have to first define a new client and configure it. We're going to write constdb equals new pg.client. So pg comes from that module we just imported, and it has a class called client. And we can construct that class by giving an object that contains all of the required properties. And the only thing that you really have to change is if you changed your name of your database from world to something else, if you named it something else, then you will need to match it. Hopefully you named it the same and you can keep it as world. The password will be the password that you set when you first installed Postgres for your default user, which is Postgres, and leave the port as 5432 because that is the default port that Postgres uses to run the database. Once you've done all of that, then we can go ahead and write db.connect. And this is going to start up our connection to our database that we have defined here. Once we have connected, then we need to think about what is the point where we want to make that SQL query. Well, it's probably going to be the first time we grab hold of the homepage. And then we need to think about when we want to get hold of the data from our database. Well, we only really want to run that once when our index.js first starts up. And instead of having quiz with all of these items, we can replace it with the records from our database. So we're going to use db.query to run that SQL code, select all from capitals, and that's going to give us all the records from our capitals table, and we're going to use a callback to check if there was an error, then console log that error. Otherwise, if there was no error, we're going to set this quiz to equal res.rows from this query. So that's going to give us all of the rows in the capitals table. And finally, we're going to run db.end to close off our connection once all of that is done. At this point in time on line 34, our quiz is now replaced with an array of records from our database. Now that we've done all of that, we can leave the rest of the code as it is because it's all using that quiz array, which we've just simply updated to use our database data instead of the hard-coded data here. And we can finally open up our terminal to use nodemon to run our index.js. Now, if we head back over to localhost 3000, you'll see that every time we hit refresh, that we're getting a new country name from our giant database containing all of the countries in the world. And you can sort of cheat at this game a little bit by refreshing to a country that you at least know the capital of, and then you can continue from there. That's the only way that I figured out to make this game a little bit easier. The capital of Iceland is Helsinki. I think that's how you spell it. I have no idea. Let's hit submit. Oh, and I already got it wrong. The name of South Korea is Seoul. And let's try that. Yes, finally we got one right. The capital of Nigeria is not Lagos, but it is a different name, and I cannot think of it right now. Have a go at the game once you've built it using this giant database, and feel that success coursing through your veins, and tell me what is your top score that you're able to reach before the game ends. Now, it's not enough to just follow along, of course, so I have an exercise for you to try out all of that without any of my guidance. If you go ahead and download the other zip file in this class, 8.2 postgresread.zip, and extract that and open it inside VS Code, then you'll be able to take a look at a similar but slightly different project where we're going to use that other table that you imported, the flags table, to use what you learned in this lesson to make this quiz app work. First, again, cd over to the project folder and then use npm install to install all of the required packages. And then you'll have your node modules folder, and you can use nodemon to run solution.js. So now going back to localhost 3000, you'll see a similar but slightly different quiz. This time we see a flag and we have to guess the country that that flag corresponds to. This is maybe even more difficult depending on how much you know about flags. But, oh, okay, this one I know. I think this is Nepal. Yes, got one. And now I'm already stuck. I have no idea what this is. This is the quiz that we're building, and we're using that other table that we imported, the flags table. And you'll know that the names of the fields are slightly different here, so be careful. The name of the country here is called name, and the name of the flag is called flag. Observe your data, make sure that you know what's going on, and open up the index.js file to start updating and writing your code to use your Postgres database, the flags table, and power this game. So I'm not going to give you any more hints. I'm going to let you pause the video and try and figure this out on your own. All right, so let's run through the solution.
The fuck? Really?
Quick out. So use your PS file. Make sure that you know what's going on. Now I'm already similar modules folder and open it without any of my guidance. If you go ahead and download the over to the project.
Uh,
We only really want to run code. I'll replace with an array of records.
Salah di mana? Salah di mana? Salah di mana sih? Salah di mana ya? Kok error sih? Why? Apa yang salah ya? Oh, Nah, kok benderanya nggak muncul sih?
End to close.
Mozilla ketemu. Udah nggak ada Mozilla. Saya nggak ada Mozilla. Disuruh pakai. Asalnya aku nggak ada Mozilla, cok. So how are supposed to be at this? What? Huh? Cannot read properties of undefined within the lowercase. What the fuck? Baris berapa? Kenapa nggak mau? Apa? Berapa?
Hey guys, close off our connection once all of that is done. At this point in time on line 34, our quiz is now replaced with an Nigeria is not Lagos, but it is packages. And then you'll have your node module and then use MTM to take a look at a. If you go ahead and download, this time we see a flag and we have to guess the country. Use nodemon to run solution.js. So now going back to localhost 3000, you'll see a similar but slightly different quiz. This time we see a flag and we have to guess the country that flag card.
Udah bisa. Kok enggak? Kenapa itu? What's the difference? I see.
Corresponds to. This is maybe even more difficult depending on how much you know about flags. But, oh, okay, this one I know. I think this is Nepal. Yes, got one. And now I'm already stuck. I have no idea what this is. This is the quiz that we're building, and we're using that other table that we imported, the flags table. And you'll know that the names of the fields are slightly different here, so be careful. The name of the country here is called name, and the name of the flag is called flag. Observe your data, make sure that you know what's going on, and open up the index.js file to start updating and writing your code to use your Postgres database, the flags table, and power this game. So I'm not going to give you any more hints. I'm going to let you pause the video and try and figure this out on your own. We set because that flag is, and then to connect all of these things. Hopefully you will end the previous one we've got here. Yeah, let me know the flags and content reason, and you want to, and or create, so in the and more. Welcome to this lesson.
Coba tadi mau cek apa ya? Oh, JS. Shit. I see. Oke, sekarang.
npm install to lesson on querying data using Postgres. Now, in the last lesson, we looked at how to read the data from our database, how to view our database. In this lesson, we want to do a deeper dive into this process and see all of the different ways that we can use that select keyword in SQL and how we can query our data and search through our database to find a specific piece of information that we want to use in our applications. The data we're going to be using to practice our SQL skills is the total amount of food produced by various countries in 2021. And the two foods that are focused on are rice and wheat. And if you take a look in the current lesson, you'll see a file that's downloadable called world-food.csv. Go ahead and download that file. And what we're going to do is we're going to put this data into a Postgres database. So we're going to create a table for the world food production data. And if you take a look at this quick graph that I created in Excel, it's basically a bunch of different countries, 9 of them, and we've got data on the amount of rice and the amount of wheat produced in million metric tons. So it's a lot of food, and we can see some of the big players like China, India, US, and we can see also the breakdown of different types of grain that they produce. For example, the US produces way more wheat than it does rice, and India produces way more rice than it does wheat, and so on. So this is our raw data that we're going to be working with, and of course, it's kind of interesting to know which types of foods are produced in different countries. The first exercise is a bit of revision. I want you to use pgadmin and the CSV file that you just downloaded to create a new table in the database that we already created previously, which was called world. And inside that database, you're going to create this new table called world_food. So you're going to have to write some SQL in order to create this table. And you can take a look at the different specifications and the different columns that we're going to need. So we're going to need an ID that is going to be the primary key, the country, which is going to be character varying 45. In terms of data types, the only one that we haven't seen so far is this one, which we're going to declare as a float. And this is going to allow us to store numbers with decimal places after them. Pause the video and see if you can remember how to do this. inside pgadmin. All right, so the first thing we're going to do is we're going to open up our query tool and we're going to write our SQL. So we're going to say
Kenapa nggak mau? Gak ke save anjing, ya Allah, gobloknya. Ini lagi kenapa sih nggak bisa diimport, cok? Kok nggak mau? Tuh, kenapa nggak mau anjir? Astaga, wak dengar satu-satu malah error, cok. Emang nggak ke save, ya Allah, ya Allah. Ah, astaga.
create table and then the name of the table. So we're going to call it world_food. And then we open up a set of parentheses, and inside here we can create some columns. So the first one is going to be the ID, which is going to be serial and primary key. The next one is going to be our country, and this is going to be a varchar 45, and that's just presuming that none of our countries are greater than 45 in character length. And then we've got our rice production, which is going to be a floating point number, and we've got our wheat production, which is also going to be a floating point number. So remember, no comma after the final column. Close off the entire command with a semicolon, and let's hit run, and hopefully you'll see that query return successfully. So now if we refresh our tables, we will see our table that is now called world food. So if we try to view all the rows, then we'll see a whole bunch of empty columns. So now to import some data in, we're going to right click on that table, click import export data, select the location of the CSV that you downloaded just now. In my case, it's in my downloads folder. And then making sure that you've got import selected and not export, making sure that in the options you've got the header selected. One important thing to notice before we hit import is if you open up the World Food CSV inside VS Code, you'll see that there is no column for the ID of each of these records. Instead, we want Postgres to auto-generate the ID for our primary key. When you're importing, make sure that in the columns to import, we cross out the ID because that one we actually cannot import. We don't have the data for it. Instead, we're relying on Postgres to auto-generate it. So now click OK, and that should all be successful. If we go ahead and take a look at our data, you'll see that all of the IDs were automatically generated from 1 to 9 because we set it to serial. You can see that we've got 9 countries in total, and we've got their rice and wheat production imported into here. So if you ever play Catan, the board game, then these are all very important pieces of data. So now that we've added our data into a database and created that new table, we can take a look at all the different ways that we can work with select to select or query different values from the table. The first one you've already seen, which is to select everything from a table, and everything in SQL is represented by an asterisk. This means select all from a particular, and then in this case, we insert the name of our table. The goal is to go ahead and select everything from the table, and if you want to try this out, then you should click on the query tool and write your query in here. See if you can get hold of all of the rows and columns from our table. Should click on the query tool and write your query in here. See if you can get hold of all of the rows and columns from our table called world. Food. All right, so it's from all of the rows and columns. To select only one column, we want to isolate a column from the table. And the reason why you might want to do this is, let's say you had a database where you had a table of customers. You want to get hold of every customer's phone number so you can call each and every one of them up wishing them Merry Christmas. So then you might want to select the telephone column, right? And the way you do this is you use the select keyword, and then you insert the name of the column and then the name of your table. In this exercise, I want you to select the pause the video, all right, of the table here. Now, what if you want to select multi-columns, comma, select yourself in the next slide. Drill this down. All right, calculate against before we pull up our data. So we don't just want all the columns or all of the rows, we actually want to check for a condition. Well, in this case, you're going to need the where keyword. Where comes from SQL and it's used at the very end, usually. We'll select a column from a table. Up to this part, you're already pretty familiar. Now, the last part is just to filter or to check against a particular condition. And the easiest condition to check against is the equals, which is represented by an equal sign. Go ahead and use this formula to try and check for the rice production of the United States. And if everything goes well, you should get a table with just one single row and one metric. We check against what? In this case, we're checking a particular column's values, in this case, the country column, for a match that equals United States, and it is included in these single quotes to represent a string in SQL. And then we tell our SQL what we actually want from that entire row of data. We only want its rice production. So we specify rice production in the select part. And at the end, all going well, you end up with a result that pulls up a single value. And this is useful when you imagine you're using a database that is backing up your web app. Say you wanted to check a user's balance in your app. Maybe you have a calling application like Skype and you want to know, well, how much credit have they got? So then you would need to select the credit from the user payment table, maybe, where a username is equal to a particular value. This really drills down deep into an array of comparisons. So lesser than the validation is with the country, because that is here, and we'll go through the solution together. All right, so first we selected on country of the condition. We're looking at wheat production greater than a loose match. Sometimes you want a shortened and refined table. Sometimes you might want to match only a specific part of your data. For example, states, but it could also be called the United States of America, right? These are both ways that this particular country could be stored in our database. Now, let's say that we don't actually remember which one we stored, and we just want to search for the United States. If it was this case, and we used an equal, so we said something like where country equals United States, then this is going to be a no match. But we can use fuzzy logic using the like keyword to check whether if a pattern exists in the data. What do I mean by this? In SQL, we can use the percentage sign to represent a wildcard. If we were to check for United, and then we use a double pipe, so two straight lines. If you can't get hold of these characters on your keyboard or you can't find them, then just Google for the pipe symbol, and you can copy and paste it from Google. If we have two strings, United, double pipe, and then a string that represents the percentage sign, what the double pipe is going to do is it's going to merge the two of them when it checks it. So it'll merge it into United percentage. And this is telling SQL that we want to look for a pattern where it is United, and then it could be anything. It could be United States, it could be United States of America, it could be United Kingdom in this case. So just be careful with using these patterns, and you have to understand how it works. What I want you to check is in our table, look inside the countries column and find all the countries that start off with a letter U. That is Ukraine and that is United States. Pause the video, see if you can apply this pattern into a where like SQL command. All right. This is the first time you've seen this. Don't beat yourself up too much if you didn't manage to get it to work. The answer should look something like this. First part, easy, similar to before. Now, next part is our condition, where the country column is similar to this particular pattern. And that pattern is U as a string, double pipe, which is a merge or a concatenate. And what we want to merge is the U with the percentage sign. So now when it checks in our table, it will check for all the countries that have a string that begins with a U and it doesn't really care what happens afterwards, Ukraine or United States. If you didn't manage to do it this time, don't worry, I've got another opportunity for you to try out where like now that you've seen it in action. Now in this case, we want to find all the countries that end in A. We're able to get the this going at the front and then the A table. Don't be confused by the double pipe because in many modern programming languages, it means or. In this case, it means concatenate. It means merge these two things together so that they become like this. And you can, in fact, in this situation, replace this part with just this. But as you'll see later on when we start working with code in our backend, we're going to be using a expression. So we're going to be evaluating a particular variable or a particular programming expression, and we want to insert that into the like structure. You're going to default back into this situation. So I just wanted you to be aware of how to use the double pipe in SQL to combine two things or two strings to concatenate them. To install all of the required modules. And
Oh shit.
Now it's time for an exercise. And this exercise has a starting file in the current lesson, which is called 8.3 traveltracker.zip. Go ahead and unzip it and then use npm install to install all of the required modules. And what we're going to be building is essentially a website that allows us to track all the countries that we've been to. If you want to know how many countries you've been to and which countries they are, you can get these scratchable world maps that you can put onto your wall where you scratch off each country as you visit them. But in our case, we're going to use technology to build this. This is an app where we can enter a country that we've been to. And the great thing about this app is it's backed by our powerful Postgres database. We can enter some data into our database, namely some countries, and our front end will know which countries those are and display them in this beautiful way of visualizing all the countries we've been to. Once you're ready, let's get started. I want you to head into VS Code and again, making sure you've extracted the files, you've installed all of the node modules and do all of that prep work that we always have to do every single time. And now if you take a look inside the index.js, you'll see that I've got a very basic backbone of an Express app for you. Now I'm going to delete that table I already made and we're going to do it all together because this one is a little bit more interesting. Let's go into our query tool and do our usual create table. And I want you to follow along with me. This table is going to be called visited countries. And it's only going to have 2 columns. So the first one is simple. It's ID, it's serial, and it's primary key. Now the second one we have to think a little bit more deeply about. We're going to create a column called country code to represent the code of the countries that we're going to store in this table, representing the countries that we've already been to. Firstly, we are going to store it as a char2 because it is going to store the 2-character ISO country codes. But more importantly than that, we need to make sure that this field is never empty. We don't end up adding data into this table that is empty, where we just end up with a primary key or something like that. So we need to make sure that it's not null. So it cannot accept null as a input and it will reject it. That's quite an important bit of mitigating errors in the future. The other thing that we want to make sure is that we're only putting in unique values into this field because we don't want to log a country that we've been to twice. It will just add to the number of countries we've been to erroneously if we start double counting. So we want to make sure that our data is sanitized. And these 2 are some of the most common modifiers to your Postgres database columns that you will see. So not null and unique. And now that we've added that, we can go ahead and hit run to create this table. Now that we've created the table, we're actually going to manually add some data into this table. In the next lesson, I'm going to show you how we're going to do this from our Node Express backend. But for now, because we want to do the first part of the application where we just display the countries we've been to, we're going to get started by adding some data manually using pgadmin. To do that, you click on this button to add a row. And the first field we're going to leave empty. We're going to let it use the default value. And the second value is something that we have to add in because we said it should be not null. And you can see in gray what pgadmin is trying to show you is what will be added as data if you don't do anything, if you don't change any of these fields. And if you try and hit save using this button, you'll see that it's not going to accept it. And that's because country code does not accept null as a value. So we have to put something in here. So let's put in a country code. For example, let's put in FR, double click on that field and put in FR. FR is the 2 country code for France, and go ahead and hit OK. If you want to refer to the full table of 2-letter codes, you can go into your database and view it right here. You can scroll through this list of countries and you can find 1 or 2 or 3 countries that you've been to and just write down their country codes. For example, I'm going to add FR for France, which I have been to, and GB for the UK, which is where I live. And finally, I'm going to put in US for the United States of America. Those are the 3 pieces of data I'm going to add to my visited countries database manually. And you'll notice when I refresh this, the data that I added previously is gone because unless you press the save button, it's not going to be persisted. So let's do that again. Let's add FR and let's go ahead and add another one, which is GB. And finally, I'm going to add US. All right, so I've got my 3 rows of data and I'm going to click on the Save Data Changes. So now that is added to my database and you can see that the IDs get automatically generated. Because the IDs have to be unique, so if there was any previous data, for example, when I created my first piece of data that was null, that got rejected, it already hogged the first ID placeholder. So it doesn't really matter as long as the ID is unique. And this is a really important way that the primary key ensures that each record has its own unique ID. Now that I've created my table manually, and hopefully you have done too, we've now got some data in this visited countries table, and we can now use it inside our application. Now is kind of the challenging part of this whole exercise. Taking what's inside index.js, I want you to be able to make this application display the countries that you just added. And you can check how this should work by, firstly, of course, making sure that you've installed all the node modules, but then next using nodemon to run the solution1.js. So now if we go over to localhost 3000, you should see the countries that I added just now manually show up on our map. This is the US, the UK, and France showing up here. In your case, it should do the same. Now, you're going to think through how to do this. And the first thing to look through is, of course, the index.egs to see how the data in here is structured. So you can collapse this section that says AG canvas because that's our entire world map, and it is massive, and it's going to make it hard for you to scroll around in the code. Ignoring that, you can see that I've got some code already written for you inside the script tag. The first thing we do is we get hold of a value in EJS called countries, which is going to be an array of country codes. And then we split each of the country codes by a comma. This way we can get hold of each of the country codes. And this line of code basically creates an array country massive, and it's going to make it hard for you to scroll around in the code. Is, of course, the index.egs. This is the US, the UK, and France showing up here. In your case, it should do the same. Now, you're going to think through how to do this. And the first thing to look through is, of course, the index.egs to see how the data in here is structured. So you can collapse this section that says AG canvas because that's our entire world map, and it is massive, and it's going to make it hard for you to scroll around in the code. Ignoring that, you can see that I've got some code already written for you inside the script tag. The first thing we do is we get hold of a value in EJS called countries, which is going to be an array of country codes. And then we split each of the country codes by a comma. This way we can get hold of each of the country codes. And this line of code basically creates an array inside this script for you to scroll around in the here is structured. So you can collapse this section that says AG canvas because that's our entire world map, and it is massive, and it's going to make it hard for you to scroll around in the code. Ignoring that, you can see that I've got some code already written for you inside the script tag. The first thing we do is we get hold of a value in EJS called countries, which is going to be an array of country codes. And then we split each of the country codes by a comma. This way we can get hold of each of the country codes. And this line of code basically creates an array inside this script that looks something like this. So it'll become FR, and then GB, and then US, like so. And once we've gotten hold of that, we can loop through it using the for each, and then this line of code gets hold of the element by ID with the code for each of the codes in this array and gives it a fill of teal color. If we expand this world map, you can see each of the countries have their own unique ID, and the path is an SVG, which is just a shape defined in a particular format to represent the shape on the page. Essentially, this entire world map is made up of every single country drawn on the screen, and we can identify them by their ISO country codes, and we can change the background color of each of those pieces by using this line of code. Now, a couple of things to note, which is here, why are we doing this? Why are we splitting the countries that we get hold of? Because we're already getting hold of an array. Why do we need to do this? Well, the key is the console log that I've included in here, and you can run a type of the country codes that you generate from this, but you can also do a type of the countries that gets passed in here, like this. And what you'll find is that when EJS does templating, it's inserting a template string. So you're getting a string here and not a JavaScript code or JavaScript array as we would expect. So we're treating it as a string, and there is a string method called split, which allows us to split each of the items by the comma, and we know that arrays are formatted using commas, and then we could end up with our array in JavaScript again. So we can recreate it essentially. Have a think about this part, which might trip you up. And the other thing I want you to think about is think about logging what you're getting back from Postgres. This challenge is, I have to admit, quite difficult, but we're kind of at the last stages now of the course, and hopefully you've realized that a lot of programming is just about persevering through difficulties, and the harder the challenge, the more reward you'll feel at the end. I'm just giving you a little bit of heads up. You might have to spend a little bit of time thinking about this and being stuck, but it is normal, and ask any programmer. This is an entirely necessary and, if not essential, part of our growth as software developers. Be patient with yourself. Don't beat yourself up too hard. Everyone trips up, and see if you can figure out how to write the code in the index.js so that it's able to pull up the country codes from your visited countries table and then pass that data over to the index.ejs and render each of the identified country codes to change its fill color. Now, if you haven't worked with Postgres for a little while, or you're just coming back to this lesson, this is just a quick slide reminding you of how to get set up using Postgres in your Node backend. So you can pause on this video while you work on the exercise, or completely ignore it if you want to do everything from scratch yourself. Pause the video and give that a go.
Wah, hasil mantap kali, Cok. Wah, shit. Wah, sesuai dengan ngantuk kali, Cok. Wah, shit. Ngantuk parah, Cok. Gak kuat mata aku. Ah.
to are some of the most copies into this field, because we don't want to log a country that we empty. We're going to let it something that if you don't this accept entry code, and we'll do it, and you can write down their country one, or scroll through this list of countries and you can find 1 or 2 or 3 countries been with merited. Refresh this, you press this to automatically generate data. I click on obviously is gone because I'm going to add write down K as a. I'm going to show you how we're going to do this. From our node of data manually using pgadmin into this table. In the next lesson, I'm going to show you how we're going to do this from our Node Express backend. But for now, because we want to do the first part of the application, where we just display the countries we've been to, we're going to get started by adding some data manually using pgadmin. To do that, you click on this button to add and unique. And now that we've added that, we can go ahead. Full table of is automatically generated. Because now is kind of the challenging part of this whole exercise. Taking what's inside index.js, I want you to be able to make this application display the countries that you just added. And you can check how this should. You should see the US do the same. Now is, of course, the index.egs, this and its code already. We get that looks get each if we say and gives it a percent. These can also do the string. Know that extension difficult, but
Go.
You've built thinking and develop trip code from your indent. Oh, if you haven't worked
Betul. Kira bunda yang mati.
with Postgres for a little while, or you're just coming back to this lesson, this is just a quick slide reminding you of how to get set up using Postgres in your Node backend. So you can pause on this video while you work on the exercise, or completely ignore it if you want to do everything from scratch yourself. Pause the video and give that a go. do everything from scratch yourself. Pause the video and give that a go. All right, my wish is that you've tried and failed and tried again and failed again, and at the end you managed to get it to work, or
Siang. Malam. Hmm. Malam.
at least get it to partially work through logging and making sure that you've got some parts of what you're trying to achieve. So now we're going to walk through the solution together and we're going to go through it step by step. The first part of working with Postgres is importing the Postgres module. which should be already installed in your Node modules because I had included it in the starting file. If you are working with a project from scratch, then all you have to do is to run npm I, and then the module is called pg. And all you have to do is to write npm I pg, and you would install that module. Once we've done that, then we're going to set up the configuration for our database. This is code that we've used before. You can either copy it from a previous project that you got or look up the documentation on npm to see how this would work. I recommend just copying your previous code and just doing a sense check. That's probably the easiest way. So in my case, the username I use to access that particular database is Postgres. The host is localhost and it's running on port 5432, which is the standard Postgres port. The database name that I have is world, and it should be the same for you. And the password that I've set to access this database is just 123456. Yours might be different. Once we've configured our database, then all we have to do is run db.connect in order to establish an active connection with our database. The next stage is to create an app.get. And this is going to give us access to the home page when we go to localhost 3000. Now here, what you have is a query, and what we need to first establish is to query our database for the countries that we visited. We're going to run db.query, and then we can insert the SQL query that is going to get us that entire column. So remember how we use the select column from table? Well, this is essentially that. It's select column, we insert the name of the column we want, and then the name of the table we want, just like this. And then once we get hold of the result, it's a good idea to console log result.rows just so you can see what the structure of the data looks like. And it actually looks like this. It's an array with lots of different JavaScript objects. Each object has a key which is set as the country code. And then it has a value which is the code that actually exists in the record. Because we have lots of these values in the array, then in order to get hold of each of these values, what we need to do is to run a for each. I created an empty array called countries, and I loop through each of the rows in our results. And for each of the countries or each of the records in there, I'm accessing the .country code. Remember, if we type in dot and then the key, we get hold of the value, which is what we want. And then we push each of these values into this empty array. So then at this point, if you console log, countries should look like this. It's an array of the various country codes. In my case, it will be GB, FR, and then finally US, like this. I'm not sure that's the right order, but this is essentially the structure of our data. And then we send this over to our index.ejs, and we also send over the countries.length. So count how many values we have in there so that we can use it in our index.ejs. And then finally, we close our connection to the database. Now let's take a look inside the index.ejs, and you'll see that we take the countries that gets passed over and we go ahead and split the string by the comma. So we had FR, comma, US, comma, GB. Again, I've got a different order, but this part doesn't matter for us. We split the string by the comma, and this method basically creates a new array in JavaScript called country codes. Now we can loop through country codes, and for each of the codes, we try to grab hold of the element that has that ID, and we change its fill to a different color. And also, that other value that we sent over, the total, gets added into this H2 and displayed on screen. That is the whole process of how we end up with this website. Remember, none of these things here work yet because we don't have any ways of catching the post request, which we're going to do in the next lesson. But have a review of the code inside solution 1 and check against your own code to figure out if there's anything you need to figure out, if there's anything you need to fix, or if you have done it in a completely different way and it still works, then kudos to you. It doesn't have to look the same as my code. As long as it works, that's kind of all I care about at this stage. There's multiple ways of achieving the same thing. But once you're done, head over to the next lesson and we're going to continue building on this app. In the last lesson, we're working on our travel tracker application, and we learned about how to use select in PostgreSQL. And we completed the first part of our application by applying the things that we learned. So now let's do the second part of the application. And in order to do that, we need to learn how to use insert in our PostgreSQL and Node backend. Again, we're going to use the data from our rice and wheat production. If at this point of the course you still don't know that I'm just obsessed with first part of our application by applying the things that we learn. So now let's do the second part of the application. And in order to do that, we need to learn how to use insert in our PostgreSQL and Node backend. Again, we're going to use the data from our rice and wheat production. If at this point of the course you still don't know that I'm just obsessed with food, then I'm glad I've hidden it well. And by the way, how great is rice? Just good rice. And if you're not into food, a really good bowl of sushi rice is surely going to change that. In fact, sometimes I just snack on rice itself from the rice cooker. But anyways, continuing with programming, we have our table of data from various countries and their rice and wheat production. And we're going to use that table to learn to add data into the table. The key word here is the insert command, and you've seen this previously when we looked at SQL in the last module. But essentially what I want you to do is to take that table that you've already got, which is called world food, and I want you to insert a new row or a new record of data. And the data is for Italy, so that's the country name, and then 1.46 is the number of million tons of rice production that happens in Italy, which is actually surprisingly large. So slightly obscure fact, if you're based in Europe, most of the sushi rice that you're eating produced by all of the Japanese sushi rice companies is actually produced in Italy. They seem to be some sort of rice specialists of Europe. And then this is the amount of million tons of wheat production they produce. So we're going to insert that into our table, and the pattern looks like this. So we have insert into, and then the name of the table, and then after some parentheses, the columns that we want to insert to. And then finally, we can add the values, and the values are separated by commas, and the columns are also separated by commas. Before I reveal the solution, I want you to have a go trying this out. So pause the video and see if you can complete this. All right, so let's go into our world food and let's view all our rows. You can see it goes up to the 9th country, United States. And now we want to use our query tool to insert our data. The keyword is insert into, and then it's the name of our table, which is world food. And then we have a parentheses that sets which columns we want to insert into. So we're going to leave the ID because that can be auto-generated, but we need to add the country, the rice production, and the wheat production. The order here needs to match the order that you're going to add the values in. The next stage is to add the values. And again, we need a set of parentheses, and we're going to add in the values in order. First is the name of the country, which is Italy. And remember, to insert strings in SQL, we need a single quote. And then it's the number of million tons of rice production and wheat production, which is 1.46 and 7.3 respectively. Now we've got our values, we've got our columns. We can now go ahead and cap off this command with a semicolon. So now let's hit run, and hopefully everything went all right. And we can now go ahead and view our data, and you can see that so 3 respectively. Now we've got our values, we've got our columns. Let's hit run and view SQL new data, and we're going to have application table, and we can go ahead and save that code into the visited countries table. Is called countries, and usual to fixed on country names like the Democratic Republic of Congo, etc. The CSV contains the ID, the country code, and the country name, and you're going to create the table using SQL, and then you're going to go ahead and import the data from countries.csv. Pause the video and complete this challenge. All right, let's go ahead and do this together. Challenge. All right, let's go ahead and do this together. In PG Admin, I'm going to go ahead and go to my query tool, and I'm going to write the create table. Table name is countries. And then I'm going to add 3 columns. So the ID, which is a serial primary key. The next one is going to be the country code, and this is going to be a fixed length char, so just 2 characters. And then we've got the country name, which is going to be a variable character length varchar, and we're going to set it to 100. Now let's go ahead and run this code to create our table. And then once we've got that table, then we can go ahead and import some data into it. And if you look inside your downloads or wherever you saved your countries.csv, let's go ahead and use that as the import. And then making sure that header is checked and all the columns this time have data. So we're going to import all of them. Let's click OK. And once the process has completed, we can take a look at all the countries we've got, which is actually quite a lot. So we've got all the countries in the world listed in here, and their corresponding country codes are matched up in the table. Now let's go ahead and use this to create the final part of our application, which you can see a demo of if you go ahead and use nodemon to run solution2.js. Now, if we go to localhost 3000, we can type in a country. So a country I've been to, Japan is one of them. So now if I click add, that country will light up and get added to my travel tracker. And this is pretty cool. Recently I went to Canada, and we can just keep adding these countries, and you'll see the total count go up, tracking all the places that you've been and keeping a record of it. That's the goal. But before I release you into the wild writing code, I just wanted to draw your attention to one thing, which is that when we write SQL queries and we use the insert into command, this is how we insert values. And the reason is because our values are hard coded. We already know what the values should be, and we're putting it in a string, a number, etc. But when we do this in our Node backend, we're going to be using dbQuery that comes from the PG npm package. And the way that this is structured is it allows us to insert two parameters. So the first one is the SQL command, and the second one are any values that we want to insert into the SQL command. And what this allows us to do is to insert not just hard-coded values like these strings and numbers, but also maybe variables or constants, or even a programming expression that you want to calculate on the fly, like 5 times 6. And the way that we do this is we write our SQL command as you know it, but then we add in the dollar placeholders for the values that we want to insert. So in this case, instead of values and then all the values, I've got my values $1, $2, and $3. The next part after the comma here is an array. And inside the array, we can add the corresponding expressions or variables that is going to be used and replaced in these positions, $1, $2, and $3. The next part after the comma here is an array. And inside the array, we can add the corresponding expressions or variables that is going to be used and replaced in these positions, $1, $2, $3, in the order that we put into the array. So this will become $1, this will become $2, and this will be inserted in position of $3. So this is just something to be aware of. But once you're ready, go ahead, head into your index.js and continue writing the code that you have in order to be able to handle the form entry that comes in here. So remember, you can check in the index.ejs to see what action the form hits up and what method it uses it, and then catch it inside your server and handle that request. Remember, we've already got body parser installed and enabled, so you can get hold of the data that comes in from the input, and then you're going to check the name of the country that the user typed in against the countries table so that you can get hold of the corresponding country code. And then you're going to save that country code into the visited countries table. And then you can figure out how you're going to use that data in the table in order to update the world map. There's several programming challenges or conundrums, and if you like a bit of a puzzle, then this one is definitely right for you. Pause the video and give this a good attempt. Again, I will say this is going to involve some thinking, some debugging, some dead ends, and some trial and error. But I believe in you, so give it a go. All right, let's go through the solution together. So if you take a look inside solution 2, you'll see that we've made some modifications to the code as we last saw it. The first thing I did was to create a new route, app.post, and that's because inside index.ejs, we've got a form that is going to post to our /add route. We can catch that in here, post, and we address it to /add, and then we've got our usual rec.res. And then here we get hold of the input, which is what the user typed in to the input in the form that has a name equal to country. This means we can basically just get hold of whatever they typed into that box. Once we've gotten hold of whatever the user typed into the input, let's say, for example, France, then we want to use that input to make a query to our database. So we use dbQuery and we use the select keyword to look for a country code from our table of countries where the country name is equal to whatever this placeholder is. And that placeholder is, of course, going to be what's in the input. This allows us to put an expression and insert it into our SQL in a dynamic way. Now it's going to search our countries table to look for France, find the country code, and then store it inside result. You might remember from before, or if not, just do a console log and you'll see that result contains a bunch of stuff, but the only useful stuff that we care about is inside result.rows. And hopefully, if all going well, we should get an array with only a single value, which is the code for France. However, if the result.rows is actually completely empty, then that means we got a no match from this query. And if the length is not equal to 0, so there is some sort of result inside result.rows, then we continue and we grab hold of the data at the first position of the row and we get the country code that is inside that piece of data. Now, how could you figure out all of this? You can either use documentation, which is a little bit arduous, or just simply use a bunch of console logs to look at the data each time and check to make sure that your assumptions matches reality, which, sometimes it does and sometimes it doesn't. We can't predict everything correctly. Once you've gotten hold of the country code that matches the country the user typed in, then we make another query, and this query allows us to use the insert into keyword that we looked at in this lesson, and we're inserting into the visited countries table into the country code column, and the value is going to be $1 replaced by the country code from this line of code here. And then finally, we go ahead and do a res.redirect, go back to the home page, which, if you remember, is going to query our database of visited countries, and go ahead and look for all of the country codes from there to display inside our index.ejs, passing it through here and here. You'll notice that I've split off this function to check which countries have been visited and then use the output back into the app.get. This is optional at this point. This is something that's going to set us up for the future as we continue refining this app. But if you have it all inside app.get, that's perfectly fine. That's exactly how I would expect. Now, if we test our app, then it should work to a large extent. So let's enter a country name. Let's try it. Let's name is equal to whatever. Continue writing the code, things and numbers, but also maybe variables or constants, or the way that this is structured. This is how to do one thing. Canada, and we can just keep adding these countries and the wild writing code. I just wanted to draw your attention to one thing, which is that when we write SQL queries and we use the insert into command, this is how we insert values. And the reason is because our values are hard-coded. We already know what the values should be, and we're putting it in a string, a number, etc. But when we do this in our Node backend, we're going to be using dbQuery.
Guys, ngantuk guys. Shit. So, oke, beberapa kali ketiduran. Udah.